Educational GMAT. Your partner in your GMAT journey.
The chair of the board of directors. This is not easy. I'll give you guys 5 minutes for this. Chair of the board of directors. Take time, don't worry. The chair. Can you tell me how many total members are there in the board? How many total members are there in the board? As per the question statement. As per this question statement, how many total members are there? Very nice. Go through it. It's not a difficult question to answer. The chair has taken an informal poll of the board members. Exactly X members, including the chair, said they would vote for the measure, while the remaining Y members said they would vote against it. So total, how many members are there? X plus Y. X are voting for, Y are voting against. Correct? Okay, all right. The chair correctly determined that the measure would not pass if all the members voted as they said they would. Okay, so let's understand this. Let's say this is for the measure and this is against. So if X voted for the measure and Y voted against the measure, would the vote pass? Would the measure pass? The measure would not pass if all the members voted as they said they would. They said they would means if X vote for the measure, Y vote against the measure, then the measure would not pass. By the way, in the context of this, what does it mean? The measure would not pass. What does it mean? Very nice. Basically, 75%. This essentially, can you tell me what percentage is for in this case? What percentage is for the measure? X divided by X plus Y into 100. This is the percentage that is for. Right? Number of members who voted for divided by total number of members into 100, right? So clearly, this is lesser than 75%. That's the reason it failed. Okay. Then the question says the measure would pass if the chair could convince just one member who said she would vote against the measure, to instead vote for the measure. So if this person votes, if this person who was against the measure, if she votes for the measure, then can you tell me how many members totally would vote for the measure? Earlier they were X, right? Now one additional member is voting for the measure. right? So this would be x plus 1 and this would be y minus 1, right? Now, if this is the configuration, according to the question, the measure would pass, which clearly means that now the percentage of members who are voting for the measure would be greater than 75%, right? So, which means x plus 1 upon the total number of members, which anyway remains x plus y into 100, that is greater than 75%. Agreed? So now if we combine the two friends, right, if we combine these two pieces of information, what do we have? What do we have? So what we have is x upon x plus y into 100 is lesser than 75, and this is lesser than x plus 1 upon x plus y into 100. Are we clear with this? Right? And that's exactly the equation that I have. X upon x plus y into 100 is lesser than 75, which is lesser than x plus 1 upon x plus y into 100. This one, right? So now it's just an inequality, and you just need to simplify this. For example, one thing what we can do is divide this entire inequality by 100. Right? If we divide this inequality by 100, what do we get, friends? X upon x plus y is lesser than 0.75, which is lesser than x plus 1 upon x plus y.
Sir, I actually have one question.
Yeah, Shamavi.
Shouldn't be x plus 1 divided by x plus y into 100 shouldn't be greater than or equal to 75? Because it is asked at least 75%.
I would be completely fine with this. Shambhavi has a very valid point, very valid point. So what she's saying is at least 75%. At least 75% would mean either 75% or greater. So I would be very valid. So it should be actually this. Shambhavi, does that take care of your concern?
Yeah.
Okay, good. So actually, let's do that. Yes. Oh, incidentally, by the way, just going from an inequality perspective, why was I able to confidently divide this entire inequality by 100? The reason is because 100 is positive. Remember, you cannot divide an inequality, or rather, you can divide an inequality only when you know that you are dividing by a positive number. Because if you are dividing or multiplying by a negative number, then the inequality sign flips. All right, since we are dividing it by 100, which is a positive number, so the inequality sign remains the same. Next, what we can do is multiply this entire inequality by x plus y. Again, x plus y would be positive because x and y are the number of members. So multiply the inequality by x plus y. So when we multiply it, what do we get? X is lesser than 0.75 times x plus y, which is lesser than equal to x plus 1. So I'm just multiplying the entire inequality by x plus y. This is just to make it simpler, that's all. All right. Okay. Now, if we consider this, what do we get? X is lesser than 0.75 times x plus y, right? So, which would be what? Which would be what? X is lesser than 0.75x plus 0.75y. So subtract 0.75x from both the sides. So what do you get? 0.25x is lesser than 0.75y, correct? And now I am dividing both sides by 0.25. So if I divide both sides by 0.25, what do I get? X is lesser than 3y. Clear? X is lesser than 3y. Okay, all right. So x is lesser than 3y is what I get by solving this. X is lesser than 3y. So by solving this, I get x is lesser than 3y. Next, let's solve this. 0.75 times x plus y is lesser than x plus 1. So 0.75x plus 0.75y is lesser than x plus 1. So 0.75y is lesser than x minus 0.75x plus 1. So 0.75y is lesser than 0.25x plus 1, right? So 0.25x plus 1 is greater than 0.75y. Oh, I'm sorry, I forgot this sign. So this sign should obviously be there, right? This sign should be there, as Shambhavi rightly pointed out. Right. And so 0.25x is greater than 0.75y minus 1, right? And now what do I do? Divide both sides by 0.25. So x is greater than 0.75y upon 0.25 minus 1 by 0.25, which would be 3y minus 4. 1 upon 0.25 is basically 4, right? So what is the other equation that I have now? What is the other equation that I have now? X is greater than 3y minus 4. All right. So x is lesser than 3y and x is greater than 3y minus 4. Now again, what do we have to do? Look for the options available that satisfy both these constraints. So x is lesser than 3y and greater than 3y minus 4. X is lesser than 3y and x is greater than 3y minus 4. Okay, now again we have to quickly look at the values. Let's quickly look at the values. Suppose that y is 4, let's say. Now, according to these constraints, then x should be what? Lesser than 3y. Lesser than 3y would mean lesser than 12 because y is 4, correct? And x has to be greater than what? 3y minus 4. Since y is 4, so x has to be greater than what? 3 into 4 minus 4, which is greater than 8. Is there any value of x? Is there any value of x greater than 8 and lesser than 12? No, we don't. Okay. Now let's take the other one. Y is equal to 7. Okay, all right, let's consider y is equal to 7. As Rohil is pointing out, let's consider y is equal to 7. So if y is equal to 7, then what is x? X has to be lesser than 3y, in this case, lesser than 21, correct? And it has to be greater than 3 into 7, which is 21 minus 4, which is 17. Any value of x that is basically greater than 17 and lesser than 21? Absolutely. 19. So in other words, the value of x is equal to 19 and y is equal to 7 satisfies this entire constraint. So 19 and 7. Yes. So let's look at it from a broader perspective. In context with this question, what we are saying is that as long as 19 members are voting for the measure and 7 are voting against the measure would fail because this would be lesser than 75% for the measure. But the moment one of these people switches from voting against the measure to for the member, right? In other words, now when there is a switch, so let's again quickly do this. As long as for the measure is 19, against the measure is 7, the measure will fail. But as if one of these members switches, which means now for will become 20, against will become 6, in that case, the measure will pass. And by pass, what do we mean? By pass, what do we mean? That for will be greater than or equal to 75%. In this case, for was lesser than 75%. In fact, I mean, if you want, you can do calculation. In this particular case, 4 would be how much? 19 divided by 19 plus 7 into 100, right? And I've done the calculation. This turns out to be approximately 73%. So since 4 was lesser than 75%, for that reason, the measure was failing. Friends, are we clear?